In this video, we are going to be proving the limit as x goes to 0 of 1 minus cosine x divided by x is equal to 0. To do so, we are going to first begin by multiplying the conjugate of 1 minus cosine x to be equal to the limit as x goes to 0 of 1 minus cosine x over x times 1 plus cosine x divided by 1 plus cosine x. With this conjugate, we can multiply it to the denominator and numerator respectively to get the limit as x goes to 0 of 1 minus cosine squared x over x times parentheses 1 plus the cosine of x. I can do this because of the formula, which says that a squared minus b squared is equal to a plus b times a minus b, with our a term in this scenario being equal to 1 and our b term being equal to the cosine x function, therefore being equal to 1 minus cosine squared of x in the numerator. This can then be equal to, if we apply our Pythagorean theorem for trigonometry, sine squared of theta plus the cosine squared of theta is equal to 1. Therefore, we can rewrite this to sine squared theta is equal to 1 minus the cosine squared of theta, which is any radian input. And we have a variable input of x, so we can rewrite the numerator to be equal to the limit as our x goes to 0 of sine squared x over x times 1 plus cosine of x. Now, sine squared x is nothing more but sine x times sine x. So I'm going to expand it out like so. And the denominator remains the same. And with this limit, what I can actually do is break up the two limits to be equal to the product of two limits. And I can do this because of a limit property, which says that the limit as our input of x approaches any number of n of the product of two functions represented by f of x and g of x is equal to the limit as x goes to n of our first function f of x times the second function as the limit approaches n of g of x. So we can break up this limit, that limit right there, to be equal to the limit as x goes to 0 of sine of x over x times the limit as x goes to 0 of sine of x over 1 plus the cosine of x. And we know from a limit property, once again, that the limit, if I write it here, as x goes to 0 of sine of x over x is nothing more but 1. We will prove this limit in future videos, but for now, just accept this as true. So this limit as x goes to 0 of sine x over x will become 1 times this limit. And we can evaluate this limit by substituting x into our ratio. So this becomes 1 times sine of 0 divided by 1 plus cosine of 0. And we know from our special angles table for trigonometric functions that this becomes 1 times sine of 0 being 0 and cosine of 0 being 1. 1 plus 1 being 2. So 1 times 0 over 2, well, what does this give us? 0 divided by 2 is 0. 0 divided by any number is equal to 0. So this becomes 1 times 0, which is equal to 0. So we have proved, therefore, that the limit as x goes to 0 of 1 minus cosine x divided by x is indeed equal to 0.